You know the feeling, right? A cold front rolls in, the temperature just drops, and all of a sudden your throat feels kind of scratchy, maybe your joints start to ache. For generations, people have blamed the weather for getting sick. But is it just an old wives' tale, or is there some real hard science behind it? Well, let's find out.
So let's get right to it. Can a change in the forecast actually make you feel ill? Well, the short answer is yes, absolutely. But the reasons why are way more fascinating than you probably think. It's not just in your head. There's a really complex scientific battle happening inside your body every single time the seasons shift.
First up, let's just confirm what so many of us feel in our bones. That sudden ache or that headache that seems to come out of nowhere when a storm rolls in, that's not your imagination. It's a real physical response to our environment. And believe me, it goes way beyond just catching a cold.
So many people report a whole range of symptoms when the atmospheric pressure changes. We're talking about everything from stiff joints and migraines to sinus pressure, just feeling wiped out, and even shortness of breath. If any of these sound familiar to you, you are not alone. It's just your body reacting to the world around you.
Okay, so where does this whole battle begin? Well, the first line of defense, and the first place to really feel the effects, are your airways. Think of your nose and your throat as the gatekeepers to your body.
Now, what's really interesting here is seeing how different conditions pose totally different threats. Cold, dry air is a major irritant. It can make the muscles around your airways tighten up. That's called a bronchospasm. But, and this is key, it also dehydrates the protective mucus lining your nose and throat. But on the flip side, warm, humid air isn't harmless either. It can actually help mold grow and puts extra stress on your cardiovascular system.
And this, right here, illustrates the whole process perfectly. When you breathe in that cold, dry air, the protective mucous membrane in your airways just dries right out. It can even develop these tiny little cracks, which create the perfect entry point for viruses. So you see, it's not the cold air itself that makes you sick, but it weakens your defenses, pretty much rolling out the welcome mat for germs.
But believe it or not, the story gets even deeper. Let's zoom in now way down to the cellular level, because it turns out our immune system has this kind of internal thermostat that is incredibly sensitive to temperature.
So meet the main culprit, the rhinovirus. This is the bug that's behind the common cold. And as research from places like Yale University shows, this virus has a clear preference. It absolutely loves the cooler temperatures found inside your nose and copies itself way more efficiently there than at your warmer core body temperature.
Okay, so here's the crucial point. It's really a two-pronged attack. As you can see, the inside of your nose is about 33 degrees Celsius, which is just perfect for the rhinovirus. But here's the kicker. That cooler temperature also slows down your body's own immune response. The very cells that are supposed to fight the virus just aren't as effective in the cold. It is literally the perfect storm for a cold to take hold.
And get this, scientists have even identified a key player in this whole process. It's a protein called NF-kappa B, or NF-kP for short. You can think of it like a cellular clock that basically controls how your cells respond to an infection by telling your genes when to switch on and when to switch off. And that clock's speed is directly tied to temperature. At a lower body temp, around 34 degrees, the clock slows way down, which weakens the immune response. At a normal 37 degrees, it runs just right. But during a fever, say at 40 degrees, the clock actually speeds up, accelerating your body's fight against infection. This is part of why a fever is actually a defense mechanism.
Okay, so we've established that temperature is a huge factor, but it's not the only weather pattern that affects your health. Let's broaden the forecast a little bit.
As this chart from the Cleveland Clinic lays out, other factors are definitely at play. That drop in barometric pressure right before a storm, yep, that can trigger those aches and migraines. High humidity can leave you feeling tired and sluggish, while low humidity, as we've seen, dries out our defenses. Even rain isn't totally innocent. It can make allergies worse and create the perfect breeding ground for bacteria.
So you can't control the weather, but you can prepare for it. Let's look at some simple, science-backed ways you can boost your defenses and stay resilient no matter what the forecast says.
These steps are your best line of defense. Stay hydrated to keep those mucous membranes healthy. Use a humidifier to fight back against that dry indoor air. And when it's cold, dress smartly. Just covering your nose with a scarf is a simple but brilliant trick. It uses your own breath to warm and humidify the air before it even reaches your vulnerable airways. And of course, a healthy diet and good sleep are your non-negotiables, the real foundation of your defense.
And let's not just gloss over this number. Getting 7 to 9 hours of sleep per night is when your immune system is hard at work, repairing and rebuilding your defenses. It is one of the most powerful things you can do to stay healthy through any season, hands down.
Finally, it's pretty much impossible to talk about the weather today without looking at the much bigger picture. Our personal health is directly linked to the health of our planet.
This quote from a recent review really says it all. As our weather patterns become more and more extreme, the challenges to our immune systems are only going to intensify. These effects are far-reaching, affecting really every part of our bodies and increasing our vulnerability.
Which leaves us with a final and pretty crucial question. We've just seen how exquisitely tuned our bodies are to the environment. But as that environment changes at a rate we've never seen before, how will our immune systems and our bodies learn to adapt and cope? That's definitely something to think about.